right. So do I make it like something interactive to know actually what's going on?
We actually want to edit it, so just brief, few minutes.
Okay. Good morning, sirs.
Good morning.
Okay. So I suppose we have two gentlemen here. Please, may I know your names?
Williams, my name.
Okay, sir.
And my colleague, Lawrence, also an NDT inspector.
Editor inspector. Okay, may I know the company?
Okay, we are from Enva.
Okay, Enva.
Yes.
Okay, that's good. So, Enva. So, what is Enva really into as regards to this, as specific to this, your operation now?
Okay, we came here to inspect the two boxes and lubricators, crossovers, then the side door for the neck.
Okay.
Right here offshore.
Okay.
So
And
what we are doing presently now, we are inspecting the two cross joints to see if there is any crack.
okay.
Two box joints, the welded joints to see.
Okay. So you're doing an inspection.
Yes.
Okay. So, what goal do you want to achieve here by this inspection? What's our aim?
Our aim is to see if there is any defect.
Okay.
If there is no defect on the welded joint, we see the joint is certified.
Okay.
The box is certified and it's fit for work.
Okay. Yeah, I know these tools are being used over time and they are subjected to certain types of stress depending on the type of condition being put under. So I'll say what possible type of defects could occur in this equipment that will actually need to be checked from time to time. What category of defect?
Okay,
for example,
we're looking out for cracks.
Okay, for example, for the toolbox,
yes.
We're looking out for cracks
and as well as corrosion.
Okay. So that's one. Corrosion reduces the integrity of the equipment.
Yes.
Okay.
When I put some
okay.
The most important thing like our JS H says.
Okay.
The way we stated it, visually.
Okay.
Visually, you and I and any other person see that the toolbox is neat.
Okay.
And it's free from corrosion.
Yes.
You understand? So the next step is what we're doing now.
Okay.
We're trying to get rid of the coated surface so that we have a clear surface.
Okay.
So by the time we apply our chemicals, the aerosol, it will give us a clear visual vision of what we're looking for, which is crack or discontinuity.
Okay.
Because those cracks, no matter how small they are,
yes,
they might result to a very serious condition, like failing.
Yes, failure of equipment
pulling out. So, and this is offshore.
That's a good one.
Any little incident is always very, very escalated.
Yes,
that's a bad name to the clients,
yes,
to the manager,
yes,
to the work team leader on site, and even to the workers.
Yes,
that's why we're here.
Okay, that's quite enlightening, and that's a good one. Okay, we've talked about the toolbox, talked about corrosion, talked about cracks, and we've talked about the process of identifying these cracks, in details. They had to. You guys have had to go to, extreme points to make sure that you identify every possible detail of cracks on the toolbox. So that's for toolbox now. I'm going to be asking about the lubricator. Okay, the lubricator, I know it should be something similar, but the lubricator is a quite different equipment. So as for the lubricator, what are the possible, defects that could occur in the lubricator?
Possible defects that will occur in the lubricator is internal corrosion, which stands out for loss of metal.
Okay, loss of metal.
Yes.
Okay.
So, and the techniques we'll be applying on this is called ultrasonic thickness measurement.
Okay, ultrasonic
We'll be
thickness.
doing some spot check.
Okay.
Lubricator.
Spot check.
Yes.
Whether they are spots.
Yes. We'll just pick points.
Okay.
Certain
spots.
Yes.
Okay, and check.
Kind of divide the length right now into 4 sections.
Okay.
Where we'll be taking our checks on.
Okay.
With the
That's a good one.
ultrasonic.
I think that's quite professional. So, going about this, you're going to divide this into different segments,
Yes.
to do an ultrasonic test, on them. So, what does the ultrasonic test detect? Is it the level of corrosion or level of fittedness of the metal?
It detects the level of corrosion.
Okay.
Which is to say, at the end, we now calculate for metal loss.
Okay.
We know the attractiveness of the lubricator, and we know its present condition.
Okay. So how do you certify the lubricator now? Is it in terms of the thickness or in terms of the strength?
Okay. If the metal loss is not is minimal.
Okay.
The lowest minimum, say, the lubricator is fit.
Okay.
For use. But if it's severely damaged internally, because when looking at it, you can't really see the lubricator is quite okay.
Okay.
All you have to look is the internal surface, the internal aspect of it.
So you're saying that there could be metal loss inside the internal diameter?
Yes.
Where the stem is?
Exactly.
Okay. The stem, there's usually this grease. There's usually much grease inside there. So is this still
with the grease and with the use of the lubricator, which water also gets through.
Yes.
The problem of all these things is actually the water that really affecting them.
Good.
Because grease is not something that we affect or will cause metal loss to the lubricator.
Yes,
but water,
the presence of water.
Exactly inside.
Yes. So I see water is the bad guys here now.
Exactly.
Okay. So we are saying now, I'm going to define this in a mathematical expression, that the amount of metal loss is directly proportional to the loss of the strength. Possible loss of strength.
Yeah.
Okay. Yeah, so we can say the same for both the side doors too.
Yes, exactly.
Okay. That being said, is there any other thing,
Yes, I would like to show you crossovers which we'll be working on. This is one of the crossovers.
Okay.
And you can see that you have some the mixture of water and grease.
Yes.
And the presence of water is not really too good for metal.
Yes.
But what we're going to do is to see how we can run a test. First of all, we'll do a thorough cleaning on the threads.
Okay.
Then we will now carry out our NDT procedure on it.
Okay.
We're not doing DPI, we'll be doing MPI, which is penetrant testing or magnetic particle inspection of the thread ends of these exovers.
Okay.
You're seeing here. We have 3 on ground and 1 exover from the box.
Okay.
Making it a total of 4 exovers, which is 5, and the one attached to the
lubricator.
Yes.
Okay. So we're going to be doing a DPA and MPI on this. That's penetrant. You say we're not doing an MPI, we're doing a DPI.
Either MPI or DPI.
Okay. A penetrant is magnetic
penetrant
inspection.
Yes.
Okay. So for the lubricator, we'll do an ultrasonic test. Okay. And for the crossovers, we'll do an MPI or a DPI. Okay, that's good. Considering the fact that the crossovers are like this kind of hollow cylindrical shape with the lubricator, why are they having two different, tests, two different type of tests? The lubricator is going through ultrasonic, the crossovers are going through an MPI or a DPI.
We can do DPI or MPI on the lubricator.
Okay.
Yeah, but the main thing here is the difference is that this one is something that is attached to the lubricator.
Okay.
So the most important part of it is the threaded end.
Okay.
Which has to be worked on.
Okay.
When there is pressure, if we have a defective thread,
yes,
it's that tendency
can pull. Okay.
So our job is to check